Okay, hi guys. Once again, welcome back to the 10th class of operating system concepts. And here we are going to discuss process types and management. And this is the part two, the continuation of the second lecture that I was given, right? Yeah. Before talking about these concepts, okay, let's go to a brief. It's a type of humor. Okay, you know the principle. My principle is like start studying with a humor. Okay, so let's begin. Once there was a soldier, and there was also a general. They were in a war. Okay, a soldier to a general. He spoke, "Sir, a small enemy group is attacking." And he was saying, then general replied, "Quickly, bring me my red shirt." So after the enemy's defeat, the soldier was very curious, like why the general asked for the red shirt. And the soldier asked, like, "Sir, why the red shirt?" And then the general said, "In the red shirt, if I got shot, my soldiers wouldn't be able to see my blood, so they won't be discouraged." So that was the reason, like like the general said that, "Okay, bring me the red shirt." Now the soldier, okay, after some time, like the soldier said, like, "Sir, 100 enemy tanks are attacking." So like, and the general, "Hurry up, bring me all my, like, bring me my yellow trousers." Okay, so did you get the humor? Okay, after this short humor, okay, now let's begin the session. Okay, how does the process terminates? The process types and management. Okay, it falls in the management sector. So how the process terminates? The process terminates if it executes the system called exit. So system called exit is used in the case where while we want to terminate the process, whereas the child can pass a byte to the parent through wait. Okay, and the byte are passed as an argument, and the parent receives it. This means using the wait system call, the child can pass a byte to the parent. Okay, so as like the operating system recovers the resources used by the child process to wait. This was the principal use of wait system call. We try to recover the resources all used by the child processes. And what does the fork do then? A fork is a system call that makes a near duplication of the current process, that is the parent process, which is identical in almost every aspect, okay, every way. Not everything, but close enough. That means, like, for example, a parent process is creating a child process. That means, like, a fork system call will try to create the identical copy of this parent. Okay, and not the totally identical copy, but there must be some kind of difference between this parent and the child, right? Otherwise, like, there will be a duplication of a code. So we'll discuss this later on. And the note is like the new process child gets a different process ID and the parent ID of the process as the parent process ID. Okay. Now the two processes, like I was discussing about, like how can we distinguish between them? Okay, these two processes are now running exactly the same code. Similar, identical codes are running together. But how can we distinguish between them? The return code of fork provides the information about who is the child and who is the parent. That means that the child has the return code 0, while the parent gets the process ID of the child. Why does the parent gets the process ID of the child? It's because the parent, knowing the process ID of the child, can communicate with the child and either can kill the child or like wait for the child process to finish its execution. So as if, like, also there is another situation like the fork fails. So if the fork fails, the return code will be a error code. So parent receives error code. That means if the fork doesn't fails, then the child returns some other kind of code, okay, which is different from the which is not a error code. So if the fork fails, the error code is returned, and this by this method the parent will automatically know that the fork was not executed. Okay, the fork system call was not executed. Now yeah, the child can also always find the parent by calling the system called get PID. Okay, get parent PID. This is the system call to get the parent ID. Now this is the demonstration of fork wait and exit. And in this demonstration, in this C programming, I will try to show you how the system called fork wait and exit are used. Now let's go directly to the code. Okay, we have the particular declaration of values, the printout of the statement, whereas the fork is created. Now, as I already told you before, if this fork is not equals to 0, it can be any number, right? So if this fork is not equals to 0, that means this block is a parent block in this condition. This is whole parent block. So that means like this statement is printed out, whereas the system call get parent ID, okay, the get parent process ID, get process ID, right? Like you sleep, you also pass the particular child process, like the status is also passed by the wait system call. Okay, you pass the address of the status. So the parent will receive from the child, from here, from the child block, the particular status whenever the wait is called in the child block, right? So the parent will like wait for the child to execute. And similarly, okay, now let's check out the program. This was in fork2.c. So now let's go to this fork2.c. You can see that, okay, just ignore this thing for the moment. Okay, whenever we compile, you can check out the situation. Like we'll get this kind of output. Look, the return type is 15. So also here, if you check out exit 15 is returned. Like after the process terminates, exit 15 will be returned. Like the 15 will be returned at the end. And similarly, you can check out the result. So this is a simple normal way to demo, like to see how fork wait and exit like is executed. And to check out the parent and children, we can check out the respective parent. For parent, the process ID is 54, okay, 5354, whereas for child, the process ID is 5355. That is one greater than the parent. So I already told you that process ID of parent and child are different, whereas the return is 0. Okay, and look, for this child, the parent process ID is 554. So this is this previous parent is the parent of this child. Okay, you can check out here and see. And whereas this parent can have different parent ID. Okay, so the process ID of the parent's parent is 53. Okay, 55,353. That is the difference. And when fork is returned, it returns 0. That means it is a child. Whereas fork returns some other number, is a parent. So this is the situation what we see here. Now immediately going to the next program, that is wait.c, which is going to give you more information about how to use wait and signal. We included the signal header file here which to handle all the signals, and it is immediately used here to ignore the child termination if the arguments are greater than 1, whereas the for is equal to 0, that is a child block. A particular ID, the process ID is, and the index, particular index and the process ID are printed out as a statement. At the end, like we return the wait, like return code. Okay, then lastly we print out. Okay, and this is about wait.c example. Now let's go and check out the wait.c example. If you go and check out, you will see, yeah, it is going to execute something. There, child first sleeps for 5 seconds, then sleeps for 10 seconds, then similarly it returns the return code. Okay, code is 100 and 5000. Yeah, the return value is 5. Process ID is 5378, whereas the return code is this one. Okay, and even after the parent like finish its execution, the child keeps on executing. That means that the parent process terminated before child process terminated. That means these childs are all now, this child process are all orphan, and they will be like adopted by the init process, the main process, the root process. Okay, this I have already discussed before in the previous lecture, right? Okay, similarly everything is here. Now let's immediately go back to the exec system call. What is exec system call? Is what it does is just replace the program in the current process with a brand new program. That means wherever an exec system call is called, wherever in a current process is called, what happens is in the current process, like this exec system call will call to a new program. A new brand program is like replaced with this program wherever this exec system is called. So you can see the families of exec function here. There are so many families. The return type of exec function is always integer for all the family, and you can check out the example here. Okay, the parameters are passed, and the important question you have to understand is how this exec system will replace the current program with a brand new program. It replaced by passing a parameters. Okay, and these are passed as a parameters here. Okay, and this is the idea. Now if you go and check out the example directly, you can see that okay, now giving the basic idea and the principle, what does L stands for? Exec is a system call, and L stands for list. This means the arguments, all the arguments are passed in a list. Okay. So what about the P? P stands for path. Okay. So path, the use of path is like executable file is searched in a directory is listed in path. That means path, it uses the path to search for the list of the directories to execute the file. That was the reason I told you, like this is the technique that uses to, it searches for the path and try to replace the particular program, the current program which is running, with a brand new different program. And this was the program. Yeah, the Unix standard input output is stored here. Okay, the header file is declared here. After that, yeah, after that you can check out like there is an exec system call with the particular parameters that are passed here, and the return type is an integer. So if the return type is less than 0, so we can say that the error in the exec has occurred. Whereas also we can see that there is a listing complete here after that situation. Why this situation is never reached? This is never reached because this exec system call will try to automatically replace the current program with a different program that depends on the parameter that is passed. So what happens is this program will just try to point out to the different program, brand new program. What is happening is like, what is happening is like something different is happening. Something brand new program is being executed. Okay, so this is the idea. Now let's go back to and check out the example, okay, for clarity. And if you go to the exec LP, this is a program, and if we try to run this program, what happens? What happens is like there was an error exec statement printed out, and now list incomplete. That means the error occurred for sure. I already told you that if there was no error, then this exec LP system call would have created a brand new program from this program. So this didn't happen, so there was an error. For the further information you can check out like exec LP has some following arguments, and the last argument is always a null. Okay, and arguments are passed. Firstly, the file is passed as a path for which on which the new file name is passed, on which the program like the exec LP system call tries to search for the arguments, and the arguments are passed in a list. Now going on to the next example, that is exec VE. Similarly in the exec VE, the important idea is like V stands for variables, whereas E stands for the environment, and the environment is the executable file inherited from the cell environment variables, and variables are the arguments that are passed as a sequence of variables. You can see the arguments are passed as a sequence of variables here. Then similarly system call date, system call is called. Then here also we are trying to print out the environment variable that is passed. And important idea is like environment variable can also be passed through the main function that is declared from here as a pointer to a pointer to the environment variable. Then lastly we try to call this system call exec VE, passing all the parameters, and if the integer value returned by this system call is less than 0, then the error occurs, then immediately we exit 1. Okay, similarly we get the result here. So exec VE, okay, this is the program. Now let's immediately try and run it, compile and run it. Similarly you can see it like this is the environment variable, any kind of environment variable. There was no environment variable passed, so there was some kind of error there. So even like system call date was called, so that today's date is printed out here. And lastly the error exec was created, like printed out, so that clearly shows that this exec VE system call did not execute well. Okay, so it returned a negative integer number. Okay, now some basic concepts about cooperating processes. What are cooperating processes? Cooperating processes are the types of processes which are affected by execution of another process. That means it can have the following advantages, that is information sharing, computational speed, or modularity and convenience. Right? So what are producer problems then? Okay. Producer and consumer is a type of cooperating process that we deal here. And this producer and consumer problem is a classic problem that you have to solve in operating system, in process management. And this is mostly about managing concurrent, like cooperating processes. What really happens is, like, what is happening here, like, is a producer is producing some items that is consumed by the consumer process, and two important possibilities for storage of these items are possible. That is, either you can store it in an unlimited buffer, that is practically not feasible and not possible, and secondly, you can have a limited bounded buffer, okay, which have a limited buffer size, and you try to store these items created by the producer, and whereas the consumer also start consuming the items. So the key idea is to understand, like, how shall we manage this kind of producer and consumer problem. How should we make sure that the producer won't try to add data into the buffer if it is full, okay. Whenever the buffer, the limited buffer, bounded buffer, like for example 10 items, okay, maximum size buffer size is 10. If it is goes over size 10, then the producer should not fill the items, and the consumer should not consume the empty buffer. Okay, so how to make sure that this situation do not occur is, like, we have to we try to show the solution in a simple programming concept. Okay, in this programming concept, like, we already defined the maximum buffer size as 10, then we created the item with the maximum buffer size, that is 10 number of items. Then we created two variables as a counter to, or a semaphore, or something like as a synchronization primitive to manage this kind of process. And in the producer process, what is happening, okay, let's go to the producer block. What is happening is, we loop forever, and what we do is we start producing. Yeah, after items are produced, what is done is, like, we try to check out the situation, like, we try to avoid what we have told. We try to avoid that after the buffer is reaches the maximum size, after the item is filled to the maximum size, the producer should not start producing the item. So we should avoid this situation. So this is avoided with this situation, that is this is produced with this situation, like, we create this kind of condition check, okay, and we try to avoid this. And it is strongly recommended to avoid this semicolon, like this termination signal, that is semicolon signal. Because what is it doing? It's trying to check that the buffer is not going beyond the maximum size, and if it goes beyond if it reaches 10, what happens is, like, this, the condition becomes true, okay, and nothing happens. But while this condition is not true, this kind of situation is executed, that is buffer, is created, okay, as a produce. The new buffer like the item is produced in a buffer index 1, index 0 starts from index 0. In index 0 new items are produced and we try to increment the counter. So that means in the second time new items are produced in index 1 and index 2 and similarly it keeps on going. Okay, the item is producing, is being produced. Then what is in the continuous block, what is seen is like we also look forever. Yeah, after looping forever, what is done is like we check out the conditions. Okay, like input is equal to the output, right? So what is this condition saying? Input n is equal to output. That means we try to avoid this condition that the consumer will not consume if the produced items is 0. The empty, if the producer like the produced item is 0, then the consumer should not consume the item, right? So this kind of situation is avoided. Okay, now while so nothing is going to happen if this condition exists. Okay, while this condition, beyond this condition, otherwise the index, the consumer's index is incremented and the consumer starts consuming the item, okay, in the next C. That means in the next buffer. So the buffer item for the buffer index 0, the consumers will start consuming, and then similarly we also increment the counter, and then it goes on forever and forever. Okay, now this was all about the synchronization in operation consuming. Now let's go to the thread concept of thread. Thread is a basic unit of CPU utilization and consists of program counter, register set, and stack space. And a thread shares with its pair thread. That means one thread is working in a cooperation with another thread, and it is sharing a task domain. And a task domain consists of code section, data section, and operating system resources. Right? So while using multiple thread, that means multiple threads in the same job. This means the idea of using the multiple thread is just we want high throughput and high performance, because for one task multiple threads are trying to complete the task, and this automatically results in the high throughput, right? So while using multiple threads, one main thread is blocked and waiting while second thread of the same task can run. This was simple to understand. Like while one thread is running, another thread is just waiting for the thread to give its operating system resources, and we achieve a kind of parallelism execution process here. Okay, there are two most important kind of threads here. Okay, you have to understand that two most important threads that is used. The first kind of threads are called user threads, and the second kind of threads are called kernel threads. Okay. And user threads and kernel threads, they have their own pros and cons. So going on to the pros of user thread, user thread are fast enough. Okay, fast enough in the sense like while doing context switching. Context switching is something like CPU is switching from one thread process to another thread. So this means like the overhead is very low in case of user threads, and it can be used utilized in any kind of kernel. Okay, so that means any kind of operating system you can use user thread. So what are the cons of user thread? If the thread performs a blocking system call, all the thread of the same task are blocked. As I told you before, like only one thread has access to the operating system resources to perform the particular task. That means, so among all the user threads, only one user thread is trying to work, okay, or trying to perform the task, okay, whereas all the other user threads are blocked. And this single thread is also implemented in the sense of multiprocessor. Even in the case of multiprocessor, a user thread will always try to only run as a single thread. It cannot run as a multiple threads. Okay, now going out to the pros of kernel thread. The ready thread can be scheduled even if they belong to the task of the thread that is like that has issued a blocking system call. Okay, and multiple threads per task can be executed. That means it was totally different from the user thread, right? So the idea of user thread is in the kernel thread, is like it's not like the idea of the user thread was just only single thread running to complete the task at one time. But whereas in kernel thread you can use like multiple threads. Even in case of multiprocessor, we can use multiple threads to perform the task. It is not needed that we just concentrate in a single thread execution. And the disadvantages are it is very expensive in the sense like the context switching is very high, and that means the overhead is very huge, and the CPU while switching from one process to another process takes a lot of time, and there are just not limited kind of threads. Okay, you cannot use like unlimited kind of threads to perform a particular task. There are some kind of constraints in using threads to perform the particular task. I mean to execute the process. That means. Okay, now going out to the next topic, that is pthread, which P stands for POSIX. And the idea behind pthread is like it is simple and effective way of creating a multi-threaded application. As we discussed before, that in the kernel thread, like and the user thread, we can have like multi-thread, right? So the principle behind using pthreads, POSIX threads, are to create a multi-threaded application. It's a simple way of creating a multi-threaded application, and we can create this thread application and try and see the application. We'll see how to create the application, a multi-thread application, in the upcoming program. And also the basic mechanism principle is like you execute two tasks in parallel and try to merge back later on at the end after the task is complete. Okay, so the two threads are created. They work in cooperation with another thread, and then lastly the threads are like merged back to the single thread. Okay, and the work is done, right? And the important idea is like also you have to include pthread.h header file. Okay, now let's going back to the next question. It's like, what are the steps to create this kind of p threads, POSIX threads, and how to create a multi-threaded application is given below. Okay, there are most important 4 steps that you have to understand. It's like, first, define thread reference variable. And how do you define the thread reference variable? It's from the keyword pthread underscore and a new thread reference variable is created. Then after creating a new thread variable, reference variable, what you do is you create the entry point for the thread. That means after like you can see from the function that the entry point is created. Then after creating the entry point, we create the thread, the particular thread, that is by using the keyword pthread create with the arguments passed. And then lastly we join everything back up in a single thread, right? This was the idea. Okay, lastly you have to note that while compiling this kind of programs, this multi-thread programs, we have to use a special keyword that was like -lp thread. Okay, this is just to insert the libraries of thread, POSIX thread. Okay, now let's go to the example. Okay, to check out the example. Oh, sorry.
Non hai mangiato? Mangio quando ho fame, se non ho fame.
Save, yeah. Okay, let's go to the self.c.
Devo mangiare alle ore convenzionali che la società ti impone.
Okay, this is the program. Now let's close this previous program and let's try to compile and run this program. And after compiling and run this program, we see that there is a main thread ID is 0, where process ID is 5570. And what is the idea? And what is the program trying to show? Is just trying to show that the process is a single thread. That means the main process, that is the init process, right? The root process. For the main process, the thread is the process ID was 0, right? The idea was to show this was all to show that the whole process that was running is just a single process, and that single process, the main process, is always the process ID is 0. That means the init process. And all the other processes are the thread of the process. Okay. Now let's go back to the second example, that is creation and join. And this is the same program that we are trying to run, right? Okay, now let's compile and check this program. Yeah, okay. This was the thing I was trying to show you, guys. This is not going to run. It is just saying that undefined reference to the pthread create, pthread join, something like this. This is because we haven't included the libraries for pthread. And for this, what we have to do is we have to go on through these steps. The steps how to compile and run this kind of applications, the threaded application. This is the particular steps you have to follow. Okay, I will go through these steps step by step, and you will see through this example. Okay, for this case, is like our program is named as creation and join.c. Go to the terminal. Okay, my program. Yeah, go to first. What you have to do is go to the file, the location where you have the code, the particular C code, and change the directory to. Yeah, my file is in the desktop, in the subfolder operating system, in the another subfolder programs, and lastly threads. Sorry. Okay, let's go one by one. Sorry, I should not include the hash sign. Sorry for that. Yeah, okay. Then desktop. Okay. Yeah, you can see the operating OS. Okay. Change directory OS. Yeah. You can see the subdirectory programs. Okay. Change directory to programs. Now change directory. Yeah. Okay. Let's see what is in the program subfolder. Is we have threads folder, right? So change the directory to threads. Go to the directory. Let's see the particular program that was creation and join.c. This is the program we want to run. So what we have to do is we have to type this command, that is gcc, the name of your program, that is creation and join.c program. This is the object, like, and try to create your own execution. Give the execution name, that is creation. Okay, let's keep the same name, creation and join. This is the executable name. And lastly, you include the libraries, that is lp thread. Okay, now all is working well. Now lastly, to execute this okay, let's check out the executive file. We can see now newly the creation and join executable file is created. Now just what you have to do is you have to execute this execution file, and it is done as follows. Okay, lastly, like, after executing this executable file, we can see the result, and the result is this one. Okay, now let's go back and check the program, what was it telling about. The program was that it prints out 1000 times A and 1000 times B, right? And by creating a thread, and lastly joining the thread. Joining the thread, joining return code and the return value. Okay, you guys know that for this program we have to include the pthread header file. Now the global variable 100 is declared, whereas this process function is created. Yeah, the process is just to print out the standard error and plus try to write like 1000 times, okay, the particular code, like A or B, something like particular variable. Now what is done, it's the key point you have to understand, it is created. The thread is created here with using this keyword pthread create, and similarly the second thread is created with pthread create. Okay, then we try to check out if it is created or failed. Okay, and then lastly the return variable, and check out if the return like code is 0. Then finally you print out the return value. Yeah, after joining the two threads, you print out the return variable, printing out in the same statement. Lastly, you just check out the return variable if this is if the job is like the join is failed or not, and the result was as shown below, like given here, like we print out the firstly the thread B, we print out B 1000 times, and we start thread A and we print out like 1000 times A, then lastly we return like we join the both the threads, and the return value of both the threads A and B are printed out. Okay, yeah, this was all about how this was the first example how to show you how to compile and run this kind of POSIX thread programs having multiple thread application, something like that. Now let's go to the third example. In this third example, we also try to illustrate somehow like the difference between the exit system call and the POSIX pthread exit call. Okay, and the difference for your idea that the difference is just that exit, the system called exit will exit and end all the threads, all the kind of threads that was created, whereas POSIX thread exit, that is pthread exit, will end the only the issuing thread that is issuing. So that means if a thread for only pthread exit is created, POSIX thread like thread 1 executes this kind of exit statement, then only this thread is exited. And here the program goes like this. Okay, going through all these programs, and lastly the conceptual idea is like here. If the arguments is greater than 1, it sleeps for 4 seconds, then pthread exit is created. Okay, it will end only the main thread, but the two created thread continue running. Whereas lastly the exit, the system called exit is created and like implemented, and lastly it exits all the threads.
Nel senso, cosa mi serve il mio corso di laurea?
Okay.
Vabbè, un po' di terminologia sì, però i cicli ad esempio non mi servono niente. Cioè più magari trasmissione del calore.
Okay, now about this try exit. Similarly, let's try and run this kind of program and see.
Sulla UAS ci sarà sicuro che chi ha fatto like.
Mo torna sotto forma di
Okay, now let's check out for the executable file. Yeah, we created the executable file, and now let's execute the executable file, that is try exit. Yeah, certain output is generated here, and you can see the date is executed, active thread. Firstly the active thread 1 was activated, then thread 2 was activated, active thread 2, then 1, lastly it was executed, right? Lastly, and all the threads get executed. And you know, for it is just to show you the basic concept, okay, how this is working. It is not like you guys have to know all these concepts by heart, okay. It is like it's just to show you like how it is working, about just to give you the idea, the visual idea about what it is going on under the hood. Now lastly, the last example is like the try common memory example. And what is this trying to, in this program, the goal of this program is to just show you that this global variable will be changed here in this thread function, 20 times, and also in the main function it will be changed here, my global variable 20 times, okay, printing out O, and lastly it is printed out as a global variable, and the global variable will be printed out 40, that is equal to the 20 plus 20 times changed, okay, is equals to 40. So the idea was like the same global variable. Common memory is as a common memory is implemented also in the case of thread, is to be, it's shown here, okay. So now let's check it out. So let's go to the, okay, let's check out that if there is a try common memory program. Where is the try common memory? Yeah, it is here. So now this is try common memory.c. Now memory, we include also the like the libraries. Okay, now let's check for the executable file. Yeah, it exists there. So try common memory. Yeah, look, it is executing here. Okay, first 20 times prints out the dot. Look here, print a dot. Okay, and then similarly in the main thread it prints out 0, yeah, 20 times. Yeah, and lastly my global equals 40, the value is printed. That means totally the global variable is equal to 40. This means this shows the common memory situation. Okay, now yeah, lastly we'll go to the process synchronization in the next session. So this is all about the session of process creation and management, and keep on listening. We'll go much in detail in the next session about process synchronization. Now this was just about the process types and management. Okay, thank you.